We're tackling a problem where a dataset has a feature with a significant right skew. This means the data is bunching up on the lower end, with a long tail extending to the right. The goal is to make this distribution less skewed using a transformation. Think of it like a lopsided slide. We want to make it more balanced. This is the core question. We'll evaluate 4 different claims about the Yo-Johnson transformation's effects on our right-skewed feature. I'll consider each claim carefully, one at a time. This statement claims that the Yo-Johnson transformation always produces a perfectly normal distribution. I will check the validity of that claim. While the transformation aims to make data closer to normal, a perfect normal distribution is rarely achieved in practice. It's more about getting closer to a symmetrical bell shape than perfect symmetry. This statement says that the transformation will lessen the skewness. This is the primary purpose of the Yo-Johnson transformation, therefore, this statement is true. It aims to reduce the asymmetry in the data. This statement asserts that Yo-Johnson handles both positive and negative data values. This is a key advantage over other transformations, like the Box-Cox method, which requires strictly positive data. So it's correct. This claim suggests that the variance of the data will always increase after transformation. However, this is not always true. The impact on variance isn't consistent. It could increase, decrease, or stay roughly the same. That depends on the nature of the data. This line introduces the scikit-learn library's _power_transform function and the specific transformation method we'll use, which is the Yo-Johnson transformation. Scikit-learn is a popular Python library for machine learning. The _power_transform function applies either a Box-Cox or Yo-Johnson transformation. Yo-Johnson is selected to handle the skewness. Let's use it to solve our problem. This line gives the context of the quiz question. We're specifically focusing on the Yo-Johnson transformation in the scikit-learn library and its ability to deal with skewed data. Understanding skewness, asymmetry of the data distribution, and the Yo-Johnson method's role in making data more normally distributed is crucial here. We also note that _power_transform is the function in scikit-learn used for this transformation. This phrase sets the stage. We're focusing on a specific statistical transformation, Yo-Johnson, and how it handles data that's not evenly distributed, skewed. It's like trying to straighten a wonky table leg. This is the core method. I'm using the Yo-Johnson transformation because it can handle both positive and negative numbers. It aims to make the data more normally distributed, making it easier to analyze. Think of it as a special tool for cleaning up messy data. This is the outcome, the data after I've applied the Yo-Johnson transformation. The hope is that the skewness has reduced and the data is closer to a normal distribution, making analysis easier. Imagine that wonky table leg now standing straight and sturdy. I'm presenting a problem involving the scikit-learn library's powertransform function. We're dealing with data that has a skewed distribution, meaning the data points are bunched up on one side and spread out on the other. The goal is to use the Yo-Johnson transformation to fix this skew. The question is multiple choice, focusing on understanding how the transformation affects the data. This statement is true. The Yo-Johnson transformation's main purpose is to reduce skewness, which is precisely what makes it useful here. I'm using the transformation to get my data closer to a normal distribution. This is also correct. Unlike the Box-Cox transformation, Yo-Johnson can handle data with both positive and negative numbers. This is a really important advantage in many real-world scenarios. This statement is false. The Yo-Johnson transformation doesn't reliably increase or decrease variance. The impact varies based on the data and lambda parameter determined by the method. This RAW refers to the core algorithm behind the Yo-Johnson transformation. I don't need to understand the mathematical details of this algorithm to answer the question, but it's good to know it exists and does the heavy lifting of transforming skewed data. The algorithm takes skewed data as input and produces data with reduced skewness. That is the overall goal of this process. The problem statement sets the scene. It clearly defines what I'm working with, a dataset with a skewed feature, and what I'm using to address it, the Yo-Johnson transformation within the scikit-learn framework. The Yo-Johnson transformation is a statistical method used to make data more normally distributed. It's a type of power transformation that's part of the scikit-learn library's _power_transform function. This function also includes another transformation called boxcox. I find the yeojohnson transformation particularly useful because it can handle both positive and negative values. This question focuses on understanding how the yeojohnson transformation affects data. We will evaluate different statements about its behavior to determine which are correct. This statement is correct. The primary goal of the yeojohnson transformation is to reduce skewness. Skewness means a distribution is not symmetrical. A right skew means the tail of the distribution is longer on the right side. Yeojohnson aims to make the distribution more symmetrical, reducing that skew. This is true. One of the key advantages of the yeojohnson transformation over the boxcox transformation is its ability to handle both positive and negative data values. This makes it a more versatile option for various datasets. This statement is false. I emphasize that while the yeojohnson transformation attempts to make data more normal, it doesn't guarantee a perfectly normal distribution. It's an approximation, not a perfect transformation. This is false. The effect of the yeojohnson transformation on variance isn't predictable. It depends on the dataset and can either increase, decrease, or stay roughly the same. It's not a consistent effect. I'm dealing with a dataset. One of its features has a strong right skew, meaning its values are bunched up on the left and have a long tail stretching to the right. This is a common problem in data analysis, and it can affect the results of many statistical methods. I'll use scikit-learn's _power_transform function, with the method set to Yeojohnson . This applies the Yeojohnson transformation, a powerful technique to handle skewed data. Yeojohnson is a type of power transformation. The Yeojohnson transformation aims to make the data more normally distributed, but it doesn't promise a perfect normal distribution. It's a tool for improvement, not a magic bullet for perfect normality. The Yeojohnson transformation is a major plus because it handles both positive and negative values gracefully. This is unlike some other transformations, like the box-Cox transformation, which only works with positive values. The main goal of the Yeojohnson transformation is skewness reduction. It aims to lessen the asymmetry in your data. I'm tackling a problem where I'm using scikit-learn's powertransform function to clean up some data. One of my features is super skewed, leaning way to the right, and I want to use the Yeojohnson transformation to fix it. I need to figure out what this transformation will do to my skewed data. I've got some multiple choice questions to answer to test my understanding. I have to pick all that apply. I'm considering if this transformation magically makes my data perfectly normal. That's a little too good to be true, right? I'm wondering if this method will lessen the skew in my data. That is the main goal here, right? I need to check if this transformation works for both positive and negative numbers in my data. Will the transformation always make the spread of my data larger? Let's find out. I'm working with a dataset and one of the features has a right skew, meaning its values are concentrated on the left, with a long tail on the right. That is what is called right skewed. I'm using scikit-learn's powertransform function, specifically the Yeojohnson method, to transform my right skewed feature. Scikit-learn is a popular Python library for machine learning. I'm focusing on the Yeojohnson transformation, a specific type of data transformation used to handle skewed data. It's a powerful tool for making data closer to a normal distribution, which is often beneficial for statistical modeling. We're using the _power_transform function from the popular Python library scikit-learn, often abbreviated as _sklearn. This function allows us to apply either a box-Cox or Yeojohnson transformation to our data. Here, we're interested in the Yeojohnson method because it's better at handling data that includes both positive and negative values. I will explore the main goal of the Yeojohnson transformation is to reduce skewness in the data. Skewness refers to the asymmetry of a dataset's distribution. A right-skewed dataset has a longer tail towards the higher values. This transformation aims to make the dataset more symmetrical, closer to a normal distribution, which is often a desirable property for statistical analyses. A key advantage of the Yo-Johnson transformation is that it can handle datasets with both positive and negative values. Unlike the Box-Cox transformation, it isn't limited to positive data only. This makes it more versatile for real-world applications where data frequently includes both positive and negative numbers. It's a misconception that the Yo-Johnson transformation will always increase the variance of a dataset. The effect on the variance depends on the specific dataset and the parameters used for the transformation. It could stay the same or even decrease. It's not a guaranteed outcome, so that statement is false. While aiming for normality, the Yo-Johnson transformation does not guarantee a perfectly normal distribution. It helps make the data more normally distributed, but some degree of skewness might remain. It's an improvement, not a perfect solution. This is the instruction for the multiple-choice question. We need to choose the statements that correctly describe the Yo-Johnson transformation.